the continuation what I discussed in the previous sessions. That is, I started with dynamic characteristics or switching characteristics. In dynamic or switching characteristics, I explained what exactly turn-on characteristics of thyristor or SCR. In the turn-on characteristics, I define what is delay time, what is rise time, and what is the spread time. And I discussed what is the importance of delay time, what is the importance of rise time, and what is the spread time. Then the total turn-on time of SCR is delay time plus rise time plus spread time. Now I want to continue with that topic. Now I want to discuss how the turn-on time will depend on various parameters. That we'll see. That is mainly that you know the turn-on time equal to, for the turn-on time of SCR, the turn-on time of SCR equal to delay time plus rise time plus spread time. Okay. Then how this turn-on time depends on various parameters. This is turn-on time. It depends on this turn-on time. It depends on following parameters. It depends on following parameters. The turn-on time of SCR mainly depends on following parameters. The first one is, it depends on type of load. It depends on load parameters. Then I want to explain how it depends on the load parameters. How the turn-on time of thyristor depends on the load parameters. Let us consider a thyristor is used to supply the RL load. A thyristor is used to supply the power to the RL load. That means how it depends on RL load, how the turn-on time depends on RL load, how the turn-on time of thyristor depends on RL load. Because of the load is consist of inductor, because of load is consist of inductor, for RL load, di by dt is less. Tell me why the di by dt is less? Yes. Inductor always opposes the rise of the current. There is no sudden change of current. If the di by dt is less, for rise of current, it takes more time or less time? More time. It takes more time. That is, if di by dt is less, TR is more. If TR is more, then what is Ton? Is high. Ton is high. That's why for RL load, the turn-on time of the thyristor is high. For example, R equal to 10 ohms, L equal to 5 millihenry. For the same SCR, let us assume that the turn-on time is 10 microseconds. For same thyristor is connected with R equal to 10 ohms, L equal to 50 millihenry. The same thyristor is connected with a load of R equal to 10 ohms, L equal to 50 millihenry. Then what the turn on time is greater than 10 microseconds. That is, if the inductance is increases, then what the turn on time of the SCR is also increases. Like this, it depends on RL load. For example, if the same thyristor is used to supply the power to RC load, if the same thyristor is used to supply the power to RC load, if it is used to supply the power to RC load because of capacitor, you tell me, di by dt is high. There is a large rise of current. Di by dt is high. Then for rise of the current, it takes more time or less time? Less time. If the TR is reduces, the rise time is reduces, then what the turn on time of the SCR is also reduces. TR is less, then T on is reduces. The turn on time of the SCR will be reduces. That's why for RC load, the turn on time is less. Like this, it depends on the load parameters. This is first one. How the turn on time of the thyristor depends on RL load and RC load. See the second one. Concentrate is how the turn on time of thyristor depends on load parameters that I explained. The second parameter is, it depends on magnitude of gate current. Turn on time is also depends on magnitude of gate current. It depends on magnitude of gate current. Turn on time is also depends on magnitude of gate current. That you'll see. How it depends on magnitude of gate current. I already told that. If IC is increases, if the magnitude of gate current is increases, if the magnitude of gate current is increases, then what about the delay time? Reduces. That means within less time, the current is reaches to 10% of IA. If the delay time is reduces, what the turn on time? Turn on time is reduces. That means SCRs which design for high gate current triggered within less time. That is, within less time, the thyristors will be turned on. For example, if for a particular thyristor, if the thyristor is designed for IC equal to 10 milliampere, the same rating thyristor, if IC is the thyristor is designed for 10 ampere, then for this type of thyristor, same rating, assume that same rating two thyristors, one thyristor is designed for 10 milliampere gate current, another thyristor is designed for 10 ampere current. Then the turn on time of this thyristor is, let us assume that 20 microseconds. The turn on time of this thyristor is 4 microseconds. That means the thyristor which is designed for high gate current, those thyristors are having less turn on time. But don't think like this. Sir, why? For this thyristor also you can apply 10 ampere, then for this thyristor also turn on time will be reduced. It's meaningless. The design for 10 milliampere. In order to reduce turn on time, if you increase continuously gate current, then thyristor will be damaged. We can apply the gate current according to design value only. Understood? Here we can apply 10 amperes because it is designed for 10 amperes to reduce the turn on time. We are designed like this. But some thyristors are made designed for less gate current. For those thyristors, you don't apply high gate currents in order to reduce the turn on time. Understood or not? Now what I am telling, if the gate current is increases, turn on time is reduces. That's why the SCRs which design for high gate current. Why you are designing the SCRs with high gate current? To reduce the turn on time. To operate the thyristors at a high frequency. Understood? The point to remember, the SCRs which design for high gate current. The SCRs which design for high gate current. Which design for high gate current. Which design for high gate current. The SCRs which design for high gate current. That is several times greater than the normal gate current requirement. Several times greater than normal gate current requirement. Normal gate current requirement. Gate current is called hard-fired or overdriven SCRs. Overdriven SCRs. We are firing with high gate current. Those SCRs are called hard-fired or overdriven SCRs. For these SCRs, turn on time is 2 to 3 microseconds. For this type of SCRs or thyristors, what is the turn on time is 2 to 3 microseconds. For hard-fired, the name itself it indicates that we are doing hard firing. Hard firing in the sense we are triggering the thyristors with high gate current. Those thyristors are nothing but a overdriven SCRs. For these thyristors, the turn on time is 2 to 3 microseconds. Okay. Like this, it depends on magnitude of gate current. Third parameter. It also depends on gate signal wave shape. Turn on time is also depends on gate signal wave shape. It also depends on gate signal wave shape. Tell me, how the turn on time of thyristor depends on the gate signal wave shape. Okay. The point to remember, to reduce the turn on time, to reduce the turn on time, a high amplitude or to take like this, a sharp leading edge. This is a sharp leading edge. A sharp leading edge. High amplitude. Okay, a sharp leading edge, high amplitude, narrow pulse width, high frequency, okay, to reduce turn on time. What type of gate signal wave shape is preferable? A sharp leading edge, high amplitude, narrow pulse width, high frequency. Rectangular pulses are more preferable. Rectangular pulses are more preferable. Rectangular pulses are more preferable. This is the selection of gate signal wave shape. A sharp leading edge, high amplitude, narrow pulse width, high frequency, rectangular pulses are more preferable. Why you are selecting this type of pulses means to reduce the turn on time. These high amplitude, high frequency pulses are having high amplitude. Because of that high amplitude of gate current, then turn on time will be reduced. It not only depends on magnitude of gate current, it also depends on gate signal wave shape. Then fourth one you remember, turn on time is also depends on temperature. It also depends on temperature. Tell me, if the SCRs are operated at high temperature, the turn on time is high or less? Yes, less. Within less time, that SCRs will be turned on. That is, if the SCRs are operated at high temperature, if the SCRs are operated at high temperature, high temperature, if the SCRs are operated at high temperature, turn on time is reduced. Why? This is the reason why the turn on time is reduced. If the SCRs are operated at high temperature means, this is the reason. Okay, we know that if the SCRs are under forward blocking mode, this equivalent, you know, this is J1 and this is J3 and this is J2. If SCRs are operated at high temperature, because of high temperature, it is having more number of charge carriers or less number of charge carriers? More number of charge carriers. Once it is having more number of charge carriers, what is the width of the J2? Yes, less. Once the width of the J2 is less, then within less time it is breakdown or more time it takes to break down? Yes, within less time it is breakdown. Once within less time it is breakdown, within less time it comes into the forward conduction mode, then what is the turn on time? Reduces. Clear? This about what exactly, how it depends on the temperature. The SCR which operate at high temperature, that SCR is having less turn on time. For example, one SCR is operated 25 degrees centigrade, another SCR is operated a condition of 50 degrees centigrade. Then which SCR is having less turn on time? The SCR which operated at high temperature, that SCR is less turn on time. Clear? Like this, it depends on various parameters. How the turn on time depends on the various parameters. Like this, it depends on the various parameters. It depends on load parameters. It depends on magnitude of gate current. Then it depends on gate signal wave shape. Then it depends on the temperature. Like this, on 4 parameters, it depends. On 4 parameters, it depends. Clear? Like this, it depends. But it also depends on junction capacitance. We know that under forward blocking mode, SCR acts as a, or SCR is equivalent to capacitance. SR. We know that I2 equal to C2 into dV by dt. I2 equal to C2 into dV by dt. If the capacitance changes, what the time is also changing. That's why it also depends on junction capacitance. That point I will give along with the turn off characters. Both turn on time and turn off time depends on the junction capacitance. Okay. This about what exactly, how it depends on the various parameters. Okay. This is the concept of turn on characteristics or turn on mechanism of SCR. Okay. This clear? Concentrate on these points. Okay. But this one note you remember, concentrate on this note that I already given. Once again I am writing here with respect to thyristor, with respect to semiconductor devices, that is with respect to switch concept, that formula I already given. But once again you note down here. Okay. You remember as a note. The point you remember, during turn on of SCR, during turn on of SCR, the current is linearly rising. Let us assume that current is linearly rising. and voltage is linearly falling. This is happening during turn on of SCR. Let this voltage is V1 and this current is I1. Voltage is linearly falling, current is linearly rising. Then what is the average energy loss? The average energy loss equal to 1 by 6 VI into T on. What is the average power loss during turn on? 1 by 6 VI into F into T on. For this derivation also I already given at the starting, but you remember like this also. What is average energy loss during turn on of SCR if the current is linearly rising? But practically it is not possible. Are you seen the characteristics now? Is there any linearly rising and linearly falling? No, there is no linear rising and linear falling. But if it is happening, then what is the average energy loss? Then what is the average power loss? Average power loss means extra frequency term we can get. Okay, this about the turn on characteristics of a SCR. Okay, how it depends on various parameters. In switching characteristics itself, the another characteristics is nothing but a turn off characteristics, that you will see. Yes, we'll see the another characteristics of thyristor in the switching characteristics itself. I'll see what is turn off characteristics of a thyristor. Yes, concentrate. Write down for this. What is the turn off characteristics? A turn off characteristics of SCR. For simply I am writing chars of SCR in the sense characteristics of SCR or thyristor. Okay. Turn off characteristics of SCR. Okay. Can you tell me what is the turn off of SCR? Turn on. What is turn on that I explained? Can you tell me what is the turn off of SCR? Yes. The process of bringing the SCR from the forward conduction mode to forward blocking mode is called turn off of SCR. Yes. The process of bringing the SCR from the process of bringing the SCR from forward conduction mode to forward blocking mode, FBM, forward blocking mode is called turn off of SCR. Is called turn off of SCR. The process of bringing the SCR from the forward conduction mode to forward. It's not reverse blocking mode. Concentrate. On and off means blocking mode to conduction mode or conduction mode to blocking mode. We don't have any operation under reverse blocking mode. That's why under forward bias condition, the thyristor is having two stable states. Forward blocking mode also stable state, forward conduction mode also stable state. On and off only. The stable states are on off under forward bias condition. That's why turn off is nothing but a not to reverse bias. Turn off is nothing but a bringing into forward blocking mode. Okay. The process of bringing the SCR from the forward conduction mode to forward blocking mode is called turn off of SCR. Then what is the process we are using? The process of turn off of thyristor is called commutation. Here we are using one technical name. The process of turn off of thyristor. Turn off of thyristor. The process of turn off of thyristor is called commutation. The process of turn off of thyristor is called commutation. This commutation. This is a technical name. How the thyristor will be turned off? That process is called commutation. Okay. Then another point to remember. Turn on of thyristor at undesirable instance. Turn on of thyristor at undesirable instance means after commutating the thyristor, after turn off the thyristor, without gate signal also, suddenly at undesirable instance, if the thyristor is turned on, then it is called commutation failure. Means we are not properly turned off. After turn off of thyristor, then again that thyristor must be turned on after giving the triggering signal. That is a reliable operation. But after turn off of thyristor, just by giving supply voltage, suddenly if the thyristor is turned off, then there is no control in our hand, then it is nothing but a unreliable operation. Then turn on of thyristor. Turn on of thyristor at undesirable instance. At undesirable instance. Turn on of thyristor at undesirable instance. At undesirable instance is called commutation failure. Is called commutation failure. Is called commutation failure. Turn on of thyristor at undesirable instance is called commutation failure. Tell me how the thyristor will be turned off? Yes, thyristor is turned off by applying reverse voltage and current is reduced below the holding current. That means to turn off the thyristor, a reverse voltage is applied. A reverse voltage is applied. A reverse voltage is applied. And anode current is reduced. And anode current is reduced below the holding current. Below the holding current. This what exactly? Turn off. Below the, do you want to turn off means we can do like this. Below the holding current. Okay, this about some introduction to the turn off characteristics. But point to remember, turn off is nothing but a current falling and voltage across the SCR. Voltage is rising. Current through the SCR is falling and voltage across the SCR is rising. That is nothing but a turn off. Now first I want to draw the total turn off characteristics. Then I will explain what is the significance of these characteristics. You draw these characteristics first, then you will see what is the significance. Okay. This you concentrate, then you draw these characteristics. This is the turn off characteristics. Yes, concentrate. and this character 6. Okay, this is T1, this is T2, this is T3, this is T4, and this is T5. Okay, then you take this time is a reverse recovery time, TRR. This time is taken as TRR, reverse recovery time, and this time is taken as TCR, gate recovery time. This total time is nothing but a turn off time of device. And this time is called circuit turn off time, TC. This is circuit turn off time, TC. Let this is anode to cathode current. This is anode to cathode voltage. Okay. Then you get the character 6, anode to cathode voltage, character 6 like this. S. This you get the character 6. We are bringing the SCR from the forward conduction mode to forward blocking mode. This thyristor is under, now it is comes into forward blocking mode. Here the thyristor is conducting now. There exists some voltage drop across the thyristor. Once thyristor is perfectly turned off, then the voltage across the thyristor is that comes under forward block. Bringing the SCR from this is under forward conduction mode. Bringing the SCR from the forward conduction mode to forward blocking mode is nothing but a turn off of SCR. Okay. Now here we are giving what is this TQ? TQ equal to device turn off time. Device turn off time. That is equal to TRR plus TCR. Device turn off time equal to TRR plus TCR. This device turn off. What is TRR here? TRR is reverse recovery time. Reverse recovery time. What is TCR? That is gate recovery time. Gate recovery time. Okay, gate recovery time. Okay. The point to remember, the turn off characteristics of thyristor is similar to that of reverse recovery characteristics of a diode. But where you have one junction, but here 3 junctions. That is the only difference. Okay? Same concept. Even though a reverse voltage is R, even though a forward current is 0, that is anode to cathode current, forward current is 0, the thyristor is continuously conduct because of stored charges in junction and layer. This effect is called hole storage effect. Means even though forward current is 0, how we are making forward current is 0? By applying reverse voltage. We are applied some reverse voltage, we are bringing that current is 0. But it not stops the conduction because of hole storage effect. Because of storage effect, it continuously conducts. When the thyristor is perfectly turned off, whenever this total current is 0, then only we can say that the thyristor is perfectly turned off. That means because of turn off of thyristor, it is taking some extra time. That time is nothing but a reverse recovery time and a gate recovery time. Understood? The point to remember, during this time, stored charges in layers, and J1, J3 is removed, During TRR time, during this time, stored charges in layers and J1, J3 is removed. During gate recovery time, stored charges stored charges in J2 is removed. In J2 is removed. That's the reason why it is called gate recovery time. I told now, J2 junction is also called which junction? Gate junction. During TCR time, we are removing the stored charges in junction. That's why this time is taken as a gate recovery time. Okay. Then that is the J2 junction. Okay. Like this, we are defining the device turn off time. Then what is the TCR? Where TC is a circuit turn off time. Where TC is a circuit turn off time. What is the difference between a device turn off time and circuit turn off time? Later on I will explain. This is circuit turn off time. This is the device turn off time and this is the circuit turn off time. Okay. Now see, that means you know that this J1, this is J2 and this is J3. This is during conduction of thyristor. This is J1, this is J2 and this is J3. If thyristor is conducting, all the junctions are closed. Now what we are doing? In order to turn off this thyristor, we are applying some external voltage, that is nothing but a commutation circuit. We are using some external commutation circuit. What exactly commutation? All this later on I will explain. Here we are using some commutation circuit. Okay. Here we are using some commutation circuit. We are using one commutation circuit. Okay. We are using commutation circuit. Now this SCR is under, we are applying, we are not disturbing this forward voltage. Then by using this commutation circuit, now what we are doing? Whatever the stored charges, what is this commutation circuit consist, which element it consists, all this I will explain the commutation methods. Now by using this commutation circuit, whatever the carriers in J1, J3 and J2 is removed. Once J1, J2, J3 carriers are removed, then all the junctions are recovered. All the junctions are recovered means all the carriers are removed. Once all the carriers are removed, automatically this commutation circuit is eliminated, disconnected. How it is disconnected, that concept I will discuss in commutation methods. Now whenever it is disconnected, now which voltage is applied? Forward voltage. With this voltage, J1 is closed, J3 is closed, J2 is open. Now SCR is under which mode? Forward blocking. That's why we are bringing the SCR from the forward conduction mode to forward blocking mode by using some circuit. This is nothing but a turn off of SCR. This is nothing but a commutation. Yes, like this we can turn off the thyristor. Now, what is the device turn off time and what is the circuit turn off time? Device turn off time is, it is time taken by the device to complete its turn off process. For turn off of device, whatever the time is taken, that time is nothing but a device turn off time. What is the circuit turn off time? It is time given by the circuit to the device to complete its turn off process. It is time given by the circuit to the device to complete its turn off process is called circuit turn off time. Or it is the time taken, a reverse voltage applied across the device is called circuit turn off time. Why you are defining circuit turn off time is for reliable turn off. For reliable turn off. What do you mean by reliable turn off? For example, let us assume that initially thyristor is conducting. Now in order to turn off this thyristor, now what I am doing? A reverse voltage is applied across the thyristor using some commutation circuit. Okay, using some commutation circuit, I am applying some reverse voltage. Now when the reverse voltage is applied, J1, J2, J3 is recovered, then automatically this reverse voltage is disconnected. How it is disconnected, that you will see in commutation method. Once it is disconnected, now which voltage is applying? Forward voltage. Now J1 is closed, J3 is closed. For example, if this reverse voltage is applied only some time only, if we are not applying for long time, only just some minimum time we are applied, then remove that one. Because of that, there is some charge carriers are mixing. If that some charge carriers are missing, now with this forward voltage, because of some charge carriers are present at J2 junction, what is the width of the J2? Less. What the width of the J2 is less. Because of this forward voltage, J2 is breakdown now. Then the resistor starts the conduction without giving any triggering pulse. This is called commutation failure. That means if some charge carriers are missing, because of that some charge carriers, J2 junction width is reduced. Then without giving triggering pulse also, just by applying forward voltage, SCR starts the conduction. That means we are not properly turned off. Then to eliminate that problem, we can apply the reverse voltage some extra time. That time is nothing but a, which one? That time is nothing but a circuit turn off time. Why you are applying some extra time voltage across the SCR? Why you are applying some extra time voltage across the SCR? For reliable turn off, to eliminate the commutation failure. That's why we are defining the circuit turn off time. One simple example. For example, we are suffering with some fever. We go to the hospital. Then the doctor will give some duration. That means he will give some time. You can use this medicine for 7 days. Then you can recover from that fever or something. Okay, you can recover. But no need to use 7 days. Within 4 days you are recovered. But why the doctor is given 7 days of time? Still if any symptoms are there, then completely you want to recover means you can use 7 days. But you are recovered 4 days. In 5th day you are not taken medicine. Again in 5th day again you can get a fever. That's why you are not recovered completely. Then still if there is any symptoms are there, some extra time you can take. That's the reason why the doctor given more time. Here also same. Within TQ time, the device is turned off. But extra time we are applying reverse voltage. Why? Yes, still if there is some charge carriers are missing, you want to remove that charge carriers also. Then some extra time we are giving. Who is the doctor given time is circuit turn off time. You are recovered now within less days now, that is device turn off time. Here also same. Circuit we are applying reverse voltage now, that is circuit turn off time. Extra time we are applying. We are recovered within less time now, the device recovered within less time now, that is nothing but a device turn off time. But always which time you can maintain more time? Circuit turn off time. Why? For reliable turn off of thyristor. Okay. Now I want to define what is the device turn off time and the circuit turn off time. That you will see. Off time. A device turn off time. That is TQ. It is time taken by the device. It is time taken by the device. Time taken by the device. The device. To complete. To complete its turn off process. To complete its turn off process. It is time taken by the device to complete its turn off process. Okay, that is device turn off time. What is the circuit turn off time? Circuit turn off time. Circuit turn off time. Okay, it is the time taken. It is the time taken. It is the time taken. A reverse voltage applied across the device. A reverse voltage applied across the device. Applied across the device. Then point to remember, for reliable turn off, that means to eliminate the commutation failure, for reliable turn off of thyristor. For reliable turn off of thyristor, always which time is greater? Circuit turn off time is greater than device turn off time. Very, very important observation. Always circuit turn off time is greater than device turn off time. Okay, like this we are defining device turn off time and circuit turn off time. Clear? This about what the turn off characteristics of a SCR. But in the diode, we are defined only TRR. But here extra TCR is also coming in the turn-off process of. Why this extra TCR is also coming means for recovering of gate junction. For recovering of gate junction in the sense to remove the charge carriers at J2 junction, it takes some extra time. That is nothing but a gate recovery time. Why it is taking some extra time? Yes, J2 junction is a more saturated junction. Why? This is J1, this is J2 and this is J3. But I am telling that J2 is the more saturated junction. But you have the doubt here, sir. How to say that J2 is more saturated? J3 is the more saturated. No, J2 is the more saturated. Why? You are telling like this now. Yes, J3 is the junction between highly doped and less highly doped. J2 is the junction between less highly doped and less doped. Even though J2 junction is the junction between less highly doped and less doped. But by connecting gate supply, we are injected some extra charge carriers. Because of some extra charge carriers are injected, then it is the more saturated junction. That's why some extra time is taken here means to recover the J2 junction means because it is the more saturated junction. To remove that charge carrier, some extra time is taken. That is nothing but a gate recovery time. Open turn off is nothing. We are applying some reverse voltage, opening all the junctions. Then automatically that reverse voltage is applied. Already forward voltage is there. Because of that forward voltage, again J1 is closed, J3 is closed, J2 is open. That is under forward blocking mode, bringing the SPR from the forward conduction mode to forward blocking mode. Now I want to explain based on this turn off time. This is the turn off time. The turn off time of device and circuit turn off time. Based on the turn off time, the devices are classified into, the thyristors are classified, mainly SCRs or thyristors are mainly classified into two types. One is converter grade thyristors and other one is inverter grade thyristors. Now we will see what is the converter grade thyristor, where we can use that converter grade thyristor. What is the inverter grade thyristor, where we can use that inverter grade thyristor, that I want to explain clearly. Understood? Is okay? Now this is about the concept of turn off characteristics that I explained.